Lesson 7-3 is applying the Pythagorean theorem to story problems. And so the first one that we're going to do, we're actually not going to do this solve and discuss because there's a lot of steps that go into it. And so we're going to, this right here is really talking about what, sorry for you guys that are watching the video, you don't know what I'm talking about, but this right here is talking about what I just talked about with my umbrella. Can I lay it across catty corner, or can I tilt it down into the box? Okay. And so obviously you need a bigger box if you're going to lay it flat, because you're going to take up more space than if you can tilt it and go catty corner, because that'll take up a little bit less space. So we're not actually going to work this, but I do want to use this space. My favorite story problem, and you will see this, it does crop up on Savvis, and then it probably will crop up even when you're doing like the I Learn, I Ready type thing. So I've got a house with the gutters 10 feet in the air. I've got a ladder propped up against the house, and the base of the ladder is 6 feet from the house. How long is my ladder? Now, when you're given a story problem like that, I am not, you guys know this from our geometry unit, right? I can't visualize it in my brain. I have to actually draw it. So when I have a problem like this, I draw it out. So what's the story problem? This is what y'all are going to do with me. We have a house. So I'm going to draw my pretty little house here. Put my little door, windows. Look at that. That's a beautiful house. Put a little roof on it. Okay, there's my house. My gutters are right here. And how high up did I say my gutters were? Anybody remember? 10 feet. Good. My gutters are 10 feet. I've got a ladder leaning against the house, right, for my gutters. I'm going to draw my little ladder in there. And the base of my ladder is how far from the base of the house? So right here, right, this is 6 feet. How long is the ladder? Can we figure that out, knowing what we know about the Pythagorean theorem? What we end up having here is a right triangle with a side length of 10, a side length of 6. And so we know that we can use the Pythagorean theorem to solve for C, and we would know the length of our ladder. Now, we're not actually going to work this out, but this, when you have a story problem, if you aren't already given a picture from your book or from the online that you're doing or whatever, or if it's an iReady or whatever, if you're not given a picture, sketch a picture out on a piece of paper, because once you actually start drawing out what it's asking, then the way to solve it just kind of like pops right in your face. Like you see it, like you can't unsee it once you draw it out. But if you don't draw it out, sometimes it can get a little hard to solve. Okay. All right. So let's look at this first example. And this is where I'm going to talk about the way you determine whether or not it's a 2D problem or a 3D problem. Okay. It says Kiana is using a kit to build the kite shown. The kit includes 3 different lengths of wooden dowels. How can Kiana decide which piece of wood to use as diagonal braces for the top or the bottom of the kite? So notice, I'm going to tell you what it's not asking first, and then I'll show you kind of how to determine. It is not wanting a brace that runs from the top to the bottom, right? Because if it was a brace running from the top to the bottom, that would be that diagonal slicing through the box. It would be 3D. But what it's asking is a brace for the top or for the bottom. So if it's a brace that's going to go diagonal, and it says diagonal right there, if it's a brace that's going to be diagonal, top or bottom, if it's across the top, it's just going to be from here to here, right? And if it's in the bottom, it's going to be from here to here. Or you could have gone the other way. It really doesn't matter. Okay, you could go this way. Oops. You could go this way, or you could go this way. Okay, it doesn't really matter. But the point being is that this dowel rod or this piece of wood is not going to slice all the way through the kite and go from top to bottom. It's just going to lay on the bottom or on the top. And if this were our kite, we would just have a piece of wood that would be right here from corner to corner. Does it go into the wood, creating a 3D problem, or does it just sit on top or on bottom, keeping it a 2D problem? You guys see the difference? So it's just a 2D problem. Well, since it's just a 2D problem, we can use a very simple Pythagorean theorem. And we know that we have, right, leg. And so the legs go on the left. We don't know the diagonal piece of wood that we need, but we know it needs to go that diagonal. It needs to be the hypotenuse. And so when we solve it, we get 35. And it's 35 what? Inches. Good. It's 35 inches. So we know that this would be the piece of wood that we would choose. We would need the 35-inch piece of wood to brace either the top or the bottom. And because it braces the top or the bottom, it doesn't slice all the way through the kite. It's not a 3D problem, it's a 2D problem, okay? If you've got a pyramid and you just want to know the diagonal of the base, it's a 2D problem. If you want to know something that slices from the base up through the pyramid, it becomes a 3D problem. So that's kind of how you can decide whether or not is the piece of wood or the line or the wall or whatever the story problem is it just on a flat surface, top, bottom, or is it actually going from the bottom to the top or from the side to the other side? Okay. All right. So on this try it, we'll do this real quick. And I want to point out some terminology here that is a little different, but I think you guys can figure it out. It says, what is the length of the diagonal D? Now, when you hear diagonal, what side of the triangle should you think? A, B, or C? Yeah, because if you think about when you see diagonal, you got to know that's your C. Because if you think about these right triangles we've been dealing with, right? This is the diagonal. It slices, it kind of, if you think of it, if it was a whole box, right? Because with the triangle, it's half of a box. That hypotenuse is the diagonal from one corner to the other. So when you see diagonal, think hypotenuse. So when it says, what is the diagonal? You got to think, what is the hypotenuse? Which means the other two that they give you are the legs. So 19 feet and 17 feet are your legs. And you're hunting for the C. Now, the book did not call me when they wrote the book. I know it's ridiculous. They didn't call and ask my opinion, right? But I would have still used C here because it is the hypotenuse. So it really is C, but they use D to stand for diagonal. It doesn't really matter. It means the same thing. Just make sure you know it means the same thing. So when we're solving for the diagonal, we're solving for the C. And on your paper, if you put C, I'm totally fine with it. All right. So we're going to plug in 19 and 17. And again, order doesn't matter on this side because we're going to be adding them together anyway. And we're going to solve for the diagonal or the hypotenuse. All right, let's start on the other side of the room today. Kiara, if you could give me 19 squared, Dayton, give me 17 squared, and Eli, you're going to add those two together. Yes. Oh my. Oh, there's one. Okay, leave your shoes. Yes. All right. Oh, you should have already had that. What are you doing? All right, Kiara, what is 19 squared? 361. Dayton, what is 17 squared? 289. And then Eli, you're going to add those two numbers together. Everybody should be punching this in the calculator for themselves. Do not rely on the overhead. Okay. Make sure, compare that you're getting what I get, but do it on your own. All right, 650. Now, right now we have D squared equals 650, and D squared doesn't help us much because we need it to just be D. So Maddie Miller, would you please? We're going to square root both sides. And when we do that, the square and the square root pop out the D all by itself. So Maddie, what do you get when you take the square root of 650? Round it to the 10th. 25.5. So it says, if the rectangle were a square, would the process of finding blah, blah, blah. Okay, so this is the process, and it is what? Feet. Now notice, because 650 was not perfect, notice what happens here. We get this little squiggly equal sign, which means estimated or almost or about. Okay, it's rounded. It's not exact, but it's rounded to the 10th. If it asks for the exact answer, and this one doesn't, but if it ever says, what is the exact answer, don't round it, you would just say, nope, don't like that. You would just say that D equals, and you would just leave it as the square root of 650, and you wouldn't reduce it. Okay, but we know that when you put that in your calculator, you get this. Okay, and those both are the same answer. One is just rounded and one is exact. Okay, but either way, we've solved for D. All right, now we're going to look at a 3D problem. Okay, and we're going to see that it's a two-step. Notice it's got, right, two Pythagorean Theorem problems going on here. So we'll talk about where you pull all the numbers from. Alex has a column aquarium with a rectangle base. Okay, so that's talking about the bottom, the base. The rectangle base has a height of 66 inches, a length of 10 inches, and a width of 14.5 inches. Well, if you know the height of the aquarium is 66, if we draw that in, okay, that's where this comes in. And then it says that the base is 10 inches and 14.5 inches. So you've got 14.5 and 10. So we've drawn our little aquarium here. You cannot find, I'm going to change colors here because I want to show you. This is what we're eventually trying to get to. Okay, we are eventually trying to get to this right here. Because we want to know what is the biggest or tallest piece of akoya wood or choya wood or whatever that is that he can put in this aquarium. And the tallest piece you can possibly put in there would be a catty corner piece going from bottom to top diagonally. Well, we can't jump right to that because right now we don't have a right triangle for that catty corner piece. But what we can do is we can focus just on the base, okay, just on the base down here. And we can find the diagonal of that, which is right here. Okay, we can find the diagonal of the flat bottom of our aquarium. And we can do that by leg squared plus leg squared is going to equal that D, or the diagonal of the base. So that's what they've done here, right? Leg squared, add them together. At this step right here, they took the square root of both, and they got, right here, they got that the diagonal was 17.6. So let's go ahead and write that in there. Okay, the diagonal of that was 17.6. I don't know if you can see that very well. Let's try red, see if that shows up any better. Does that show up a little better? Not really, it's kind of bold. All right, so we know the diagonal is 17.6. Now we've got a little bit more information about that green line, okay? Because now we actually do have two lines that equal, that are the legs if that is the diagonal. And it's kind of hard to see in this 3D image, but this would be a leg right here, okay? This would be a leg. So 66 is one leg. And the diagonal that we just found, this is why it's a two-step problem. The diagonal that we just found is actually the other leg. So, and I don't care if you call it A or B, they call this one A and this one B. So that's why you have to find the diagonal of the base first, because that actually is a leg of your 3D diagonal. So if you notice what they put in, is they put in for the legs, remember, legs go on the left. This leg, 66, was the height. And this right here, the 17.6, that came from right here, from the diagonal that we found. And those two make up the next Pythagorean theorem. And so when you square everything, and then you get to this step right here, and you take the square root of both, you get the final answer is that the longest piece of wood that you can put in this aquarium that would go diagonal from top to bottom would be 68.3 inches. So if it's a 2D problem, one Pythagorean theorem gets you the diagonal. If it's a 3D problem, you got to do one Pythagorean theorem to get the diagonal of the base or the side or whatever, just one flat top side. And then your second step is take that number, use it as a leg for your diagonal. We'll work some of these together. So hopefully it makes a little bit more sense as we go through it. All right. So the next example says, apply the converse of the Pythagorean theorem. And remember, that's just the fancy math way of saying if a squared plus b squared does equal c squared, then yes, it's a right angle or a right triangle. So that's all that converse means. If you've got a shelf, okay, and you want to fit it into a 90-degree corner, it would make sense that the shelf would need to be a 90-degree shelf. So test it, see if that's a 90-degree angle by using the Pythagorean theorem. If it is in fact a right triangle or a 90-degree angle, then the shelf will fit in the spot in the wall, in the corner, okay? So we're not going to really talk much about that one. Are you good with that? All right. Let's roll into our homework, and we are going to do it together. Look, there's one. Look, there's right there. I just now said it. You guys are going to have these. They pop up a lot, right? You're painting a roof. You place the base of the ladder 12 feet from the boathouse. How long does the ladder need to be to reach the roof of the boathouse? So this is just like that one I drew at the beginning. So you always use the Pythagorean theorem to find the length of that ladder. Okay. All right. So let's go to this number 7 and number 8 is where we're going to start. So for number 7, is number 7 2D or 3D? 2D, which means one Pythagorean theorem will get us what we need. So it says you are going to use an inclined plane, and that just means a ramp. That's what an inclined plane is. Think a ramp if you're trying to drive something up onto a trailer. Okay, it's just a ramp. You are going to use an inclined plane to lift a heavy object to the top of a shelving unit, and it sees with the height of 6 feet. So our shelf, draw the picture if you need to. Here's your shelf, 6 feet tall. The base of the inclined plane is 16 feet. Well, base always means the bottom. So the bottom right here is 16 feet. And then it says, what is the length of the ramp or the inclined plane? So we want to know this. And from our drawing, we can see that that is finding the hypotenuse. So you're going to plug in, order doesn't matter, right? I don't care which one you call A and which one you call B. And then you're going to solve for C. Now, remember, if you don't know C, C is going to stay C all the way down. Don't ever pop a number in for it. Keep C on the left or on the right side of the equation. All right, where'd we leave off? Olivia 6 squared, Maylee 16 squared, and Dalton add the 2 together. And everybody, get a Dayton, you need a good calculator. Go grab one. Beginning of class, I told everybody you need to have a good one. Sign it out. Yes. Can you what? Do you not have your book? Yeah, that's fine. Yep, just do your homework on that, and then when you get your book, just slide that in your book. It'll be fine. Okay, 6 squared, Olivia? Good, Maylee? Okay, and then Dalton added together. All right, now remember, on this side, we're trying to find C, so don't lose that just stays C squared all the way down. We haven't done anything with that side. It stays C squared. Okay, we don't know it. It's the unknown. It's going to stay the unknown all the way through our problem. Now we are here where we can take the square root of both sides because the square and the square root cancel out, dropping our C. Again, remember, our C was our unknown, so you should still have an unknown all the way down here at the end. And Micah, what is the square root of 292 rounded to the 10th? Okay, so it says the length of the inclined plane is about 17.1, and they already put feet, so we don't have to put feet because they already put it. All right, now we're getting into 3D. Okay, and you can tell because of all the dashed lines that are all those lines that are kind of in the background that you have to, these kind of test your mental vision ability. All right, so it says find the missing links in the rectangular prism. So the first thing we're going to do is, remember, look at the base of this, right? We're going to solve for S first because S is the flat bottom of our prism and it's the diagonal of that flat bottom. So if you're just looking at, let's kind of put it in purple here, this right here is our bottom, and there's the diagonal, and that's the S that we're solving for. And since they used S, I'm going to go ahead and put S over here. That's what we're solving for. It's C squared, and, you know, I'm not really too picky if you put C squared there, but since we're solving for S and R, let's keep them separate. So the S is our C here, and even though it doesn't really look it, this is a right angle because it's a rectangular prism. And we know, looking at this, all the sides of every single rectangular square prism is going to be 90 degrees. So if we know we need this, and we're not given that, but where are we? Actually are, but it's just not on the right side. What is that side length? 3. Yeah, because it's over here. So because that side is 3, we know the other side is 3. So we can make this also 3 feet, right? So if we want to know the diagonal of just the flat base, we would say the first leg is 3, right? So that's our A and this is our B. So 3 squared plus 10.5 squared is going to give us S squared. Now we're going to just keep that S squared, right, all the way down because we don't know S. That's what we're trying to solve. So that's going to stay our unknown. And Maddie R square 3 and Briley square 10.5, and then Brady add them together. 9.25. Yeah. Okay. And then Brady. Everybody should be punching this in their calculator. Dayton, put it in your calculator. Good. Okay, and then back up to the front. What? Jacob, if you would, we're going to take the square root of both sides, and we do that because we want the S to drop out just as a plain old 1S. So Jacob, what is 119.25 rounded to the 10th? Rounded to the 10th. It won't be perfect. It'll be a decimal, and so you're going to want to round it to the 10th. 10.9, is that what everybody else got? Yep. All right, so 10.9. So what that means is that if I come in here where S was, I'm going to write 10.9 for that length. All right, now I'll try to do this in a, you guys tell me if this shows up on the screen. I'm not sure if it does. Now I need to find R. And R is a line that slices 3D through that prism. And the two sides that make up the legs of this R is this and this, the one we just found. Yes. Re-square 10.5. Did you put 6? That's a common error. Thanks, guys. Okay, and you really have to kind of make your brain just visualize this 3D. Okay, so when you're trying to find R, you got to figure out what are the two sides that make up the leg of this R triangle. And I've got them highlighted in green. Now we know that the one leg length is right here because we just found it, but we need to know this one. And it's not really given to us, but it is. Where do we find it? If we need to know the height of this box, do we have it here? So we can actually put 3.5 there. You got to kind of look for clues around the box to find congruent sides that would also be the same. All right, so the two legs of this 3D image is 3.5. Okay, that's the one we just found, or that's the one that we found from the other side of the box. And then we need to take right here our diagonal that we found in the last step, and that becomes a leg in our second step. So we would plug 10.9 in as our second leg because it's right here. Right? This right here becomes the one that we found in the last step, becomes one of the legs in our R step. Okay, let's see. We're Corbin square 3.5, Jace square 10.9, and then Aiden add them together. Hang on. Corbin? 12.25, good. Jace? Okay, and then Aiden, add those two together. Now on this side, you can do R squared because that's what we're solving for now, right? We're solving for this unknown diagonal that runs 3D through the whole box. All right, what'd you get, Aiden? Everybody agree? Okay. Now, whoops, I lost a square here. Now this is R squared, and we don't want R squared, we want R, so we're going to take the square root and the square root, and Caitlin, last one, I'll give it to you. Put 131.06 under the radical, and we know that the R just drops out as an R. And what do we get, Caitlin? Rounded to the 10th. Everybody good with that? Depending on your calculator, that's what I get ready to say. Depending on how your calculator rounds, it might be 11.4 or 11.5. I've gotten both answers today, and I think it's because some of the calculators are set to round different. So I need to go through and reset all the calculators so they all round the same. But if you got 11.4 or 11.5, depending on your calculator, you've got the right answer. And then I need to write what? Good. Yes.
Like if we're doing that on like a Sabbath and it's like maybe like a test or something, if you put 11.4 or 11.5, will they both be right?
Typically, they're going to be multiple choice. So if you got 11.4 and your answers are 11.5 is one of your options, I would say that. The other thing is maybe grab a second calculator and just see if you get something different when you do it on, I'll try to remember this week or this, during my prep one of these days, or maybe one day I'll just have you all pull them out and help me do it. We just need to reset all the calculators so they all round the same. So, the actual book says 11.5. So, point what?
0.448.
So it still should round to 11.4.
Yeah, but it
Yeah.
This is 11.
Yours does? Let me see when I put it in my calculator. All right. Let me look at this. We've got what, 5 more minutes? Okay. All right, I'll give you, I want you guys to work, I'm gonna do something on the calculator. I want you guys to work through 12 on your own. I'll black out my screen, I'll work it, and then I'll turn my screen on in a few seconds and we'll compare answers. So what you've got here is you want to know what is the longest poster that you can fit in the box. So think about your poster, and I'll try to draw it in here. Your poster is going to go here, right? That's going to be your poster. But you can't find your poster until I am not good at drawing 3D images here, people. I'll just tell you that right now. Okay, there's the base. A is just asking you what's the longest, and then it says explain. Don't worry about the explain part. Just find what's the longest poster you can fit in this box. Don't worry about part B. Just do part A. To answer part A, it's a 2-step problem. Because the poster is going to fit diagonal, you got to find your diagonal of your base, and then you got to use that as a leg for your second one. Because it says what is the longest poster you can fit. And so if you think about my umbrella example, if I just put my umbrella flat, it's going to need to be a bigger box. If I angle it, my box can get a little bit smaller because the diagonal is. So if you want to know what is the longest poster you can put in there, it's going to go diagonal from top to bottom. Yes. So you guys work that, and then I'm going to come around, check your work while you're working this. Everybody should have their calculator going, their pencil going. I'll come around and check your work as soon as I check one thing in my calculator. Yes. And you can just show your work under part B. Yeah, I'm fine with that. So the first thing you're going to do is find the diagonal of your flat base that's 20 inches by 8 inches. Mrs. Borden. Okay, I'll send him down. Thanks. Here in just a second, Corbin, you need to go to the office. All right, so for step 1, we've got 20 squared plus 8 squared equals c squared. We don't know that. So what'd you guys get for C? 21 point what? All right. Now that becomes one leg of your diagonal. And the other leg is the height of your box. So everybody should be able to take it from there. So this answer right here comes up and starts out your problem with your first leg. Make sure you answer in inches. And I'm going to slide around and check your work. Good. 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 Taking care of the work real quick. You're good. 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 All right, what'd you guys get?
24.6.
24.6. All right, thank you. You guys have a great weekend. Be safe, make good choices, and I will see you on Monday. So 21.5 squared is 462. Thank you, thank you. Have a great weekend, ladies.
Thank you. Thank you. Have a good day.
Have a good one.
I wore my Brave shirt yesterday.
And I missed it?
Yeah.
Ah. Oh, I am so chipper. Wow, that's going back in time. I like it. I know I was pretty bummed I missed sports team day. All right, so to finalize our answer here, and then I'll get off the video as well. We get C equals 606.25 as a square root, and we get, it's not equals, it's estimated 24, and we're going to round to the 10th, so it becomes 24.6, and it is inches, so our answer is 24.6 inches. Miss Borden? All right, for those of you at home, if you have any questions, go ahead and shoot me an email. But if you, as long as you watch the video and you did these 3 problems together, then you can show me when you get back to school that you have the homework done, and I will put your grade in the grade book.